Let's take a look at problem number 17. Factor difference two perfect square trinomial, or two perfect squares, and factor something else. I cut some of it off when it came out of the test bank. We got 25q squared minus 60q plus 36. And with the perfect square trinomial method, we have our setup goes like this. It's always the same, except for sometimes there's a plus right here. And you try to see if you can rewrite this as something squared. Well, 5 times 5 gives you 25, and q times q gives you q squared. And 6 times 6 gives you 36. Now, whatever's in the first set of parentheses here would go first here, and whatever's in the last set of parentheses would go last here, if this method would work. Well, 5 times 6 is 30, times negative 2 is negative 60, so it would work. Then if you can write it in that form, then you take what's inside your first set of parentheses, this sign here carries down, minus what's in our last set of parentheses, squared. So our answer is 5q minus 6 squared, which is C. Now the formula for this is a squared minus 2ab plus b squared is going to equal to a minus b squared, where a and b can be anything. And the one that goes along with it also is a squared plus 2ab plus b squared is equal to a plus b squared. Now you run across this so seldom in math that I always tell people just go ahead and use a key number. It's a little bit of extra work, but considering there's probably, especially when you get to college algebra, considering there's probably only one in an entire book that you could benefit from using this method, it's not really hardly worth memorizing these formulas for. Key number is a little bit extra work, but it'll give you the same answer.